All right, so what we're being asked to do is to find 5 ordered pairs for this equation. So the idea is we want to find, and I'm going to write this, 3x plus 1. Okay, so what we want to do is we want to find 5 solutions, and that's basically what an ordered pair is. It's a pair of values for x and y that make this equation true. And it's really easy because this formula, this equation, is arranged in such a way that you choose any value you want, and in this case, my math lab chose -2, -1, 0, 1, and 2. So they chose those for us, but we could have chosen 7 or 9 or -2.3. We could have chosen any values for x. And now we're going to plug in the x and calculate what the resulting y will be. So let's do that. So we're going to do, and first we're going to start with -2. So it's going to be 3 times -2 plus 1. So this is -6 plus 1, which gives us -5. So what that means is when x is -2, y is -5. All right, and so now we can erase this portion. Well, actually, I think what I'm going to do is I'm going to put it way over here. And now we're going to do -1. All right, so we've got 3 times -1 plus 1, so that's -3 plus 1, so that's -2. So that means when x is -1, y is -2. And I don't need that, so I'm going to put it over here. I'm going to make these a little smaller because we don't need them anymore. And now it's time to do 0. So that's a really easy one. 3 times 0 plus 1. So that's 0 plus 1, which is 1. So that means our ordered pair is 0, 1. I'm going to move that over here, shrink it down. All right, and now we've got 3 times 1 plus 1, so that's 3 plus 1, so that's 4. So our ordered pair becomes 1, 4. Why is it 1, 4? Because we inserted the 1 for x and we calculated that 4 is our value for y. And then we're going to put that over here. Don't need these, so we can get these out of the way. And then our last one is 2. So 3 times 2 plus 1, so that's 6 plus 1, which is 7. And so our value, our ordered pair, is 2, 7. And so we've gotten these out of the way. Now you remember, and I'm going to get that guy out of the way, that each of these is an ordered pair. And what that means is we have -2, -5, and then we have -1, -2, and then we have 0, 1, and then we have 1, 4, and then we have 2, 7. All right, so each of these is a solution to the original equation. And let me pull that original equation down here. All right, so each of those is a solution. So now what we're going to do is we need to take these points and put them on the graph where they belong. So where does, let's start with -2, -5. Where does that go? Well, that means to the left 2, down 5. So that means it's going to go right here. So -2, -5 goes right there. And then, and by the way, we're doing these in no particular order. It doesn't matter which one we grab next. So let's do this one. So where does 0, 1 go? Well, 0, 1 is going to go right here. So there's 0, 1. And how about where does -1, -2 go? Well, -1, -2 means you're going to go to the left 1, down 2. So that's going to go right here. So we're going to drag that down there. And then how about 1, 4? Whoa, whoa, oh shucks. let's see, does that go? Yeah, there we go. Fixed it. All right. So where does 1, 4 go? Well, that means you're going to go over 1, up 4. And so that's going to go right here. And let's move that over there. And you'll notice these are all forming a line. All right. And then the last one is 2, 7. So that means we're going to go over 2, up 7. And there it is, over 2, up 7. And there's our point. And you know we did it right because all of these dots are forming a nice straight line. And that's what the graph is going to look like. Now I want to point out something that's kind of, I'm going to foreshadow a little bit here. So the idea is I want you to recognize a neat relationship. All of these dots are, there's this neat pattern that goes starting at this dot, let's say. It doesn't matter which dot we start at, but, and I'm going to do it in green. That to go from this dot to this dot, we go up 3 and we go over 1. So we're going to call that a slope of 3. All right. And you'll notice slope of 3, here's a 3. And that's not a coincidence. Now, we could even skip a dot if we wanted to. We could start at this dot and go up to this dot, skipping this dot. Now, what happens if we do that? Well, if we do that, to go from this dot to this dot, you always start with your vertical, then your horizontal. And so what did we do? Well, we went up 1, 2, 3, 4, 5, 6. So we went up 6 and we went over 2. And look at that, 6 over 2 is equal to 3 over 1, which is equal to 3. And look at that right there. So that's a little bit of foreshadowing into a subject that we're going to go into in future videos. So let's do more. So it says complete the ordered pairs so that each is a solution of the given linear equation. So now we have this new equation, and this new equation is kind of funky. And let's get it a little bit larger there. It's a little funky. It's x is equal to 5 minus y. And again, over here, they give us some values of x that they want us to use, 0, 1, and 5. We could have chosen any values of x, but they wanted us to use 0, 1, and 5, so let's do that. So now we're going to use, let's get back to my blue. X is 0, then we're going to calculate y. So that means x is 0, and then we need to calculate y. Well, 5 minus what gives us 0? Well, it turns out y has to equal 5, because 5 minus 5 is 0. So y has to be 5. So that gives us this ordered pair right there. So I'm going to, whoa, stinker. So I'm going to get this guy out of the way right there. All right. And, okay. And now we are going, whoa, what? Oh, there we go. That's the way I want it to look. There we go. And so now, I'm going to get this guy back up out of the way here. And so now we've got x is 1. So let's do that. So x is 1 equals 5 minus y. So it says 5 minus y has to equal 1. Well, that means y has to be a 4. So now we know that y has to equal a 4. So I'm going to move these guys over here. And so y minus 4 y equals 4. So that goes right there. All right, so getting these guys out of the way. In fact, I can shrink them down a little bit, get them out of the way. And then the last one. So now we have x is 5. Well, if x is 5, 5 minus what equals 5? Well, y has to be 0 in order for that to work. So y has to be a 0. And so I'm going to put that way over here, get it out of the way. I'm going to take this guy and move it over here. And here are our ordered points. Our ordered points are ordered pairs. 0, 5. Then we have 1, 4. And then we have 5, 0. So those are our 3 points that we need to graph. And so where are those dots going to go? Well, let's start with this one, 5, 0. So that's going to go over here at 5, 0. And then we have, let's do this one, 0, 5. So 0, 5 is going to go right here at 0, 5, and you can already start to see a line, possibly. This guy is going to be the like the correction. It'll either fit on the line or it'll be way over here and we screwed up somewhere. So the idea of where is 1, 4? Well, 1, 4 goes right here. And sure enough, you can see that there is our line. So this time it's the same kind of problem, but this time you'll notice we have an equation, and let's get that written down first. So that equation is x minus y equals 5. But this time, they're kind of bouncing around. First, they give us y as equaling 0. Then they give us x as equaling 1. And then they go back to y equaling -2. And each case, you substitute in the value that you know, and you have to use logic or algebra to figure out the missing variable. So let's start with y is equaling 0. So that gives us x minus 0 equals 5. Well, using logic, x minus 0 equals 5, well, that means x has to equal 5, because that's the only way you could get 5. 5 minus 0, 5 minus 0 equals 5. So x has to be a 5. So let's put that out of the way, shrink it down a little bit. So x is equaling 5 right there. And so now we're going to do 1. So now x is equal to 1. So x is 1 minus y equals 5. Ooh, this is a little tricky. So 1 minus something equals 5. How do you subtract and get a larger number? You're starting with a 1 and you're subtracting to get a larger number. Well, that means y has to equal -4. All right, so how did we get y is equal to -4? Well, y is equal to -4 because, I'm going to squeeze that in here, -4. So the way you subtract, let's go here, the way you subtract is the minus sign turns to a plus sign, the second number turns to its opposite, and so now you have 1 plus 4 equals 5. So that means y, in order for that to work, y needed to be a -4. All right, so we're going to get there, and I'm going to shrink this guy a little bit. And then, so let's get that out of the way. Group. Can I group? What the heck? And all right, so now, there we go. All right, so now, so y is equal to -4. So I'm going to squeeze in a -4 there. And then finally, we're going to do this again, only now y is -2. So y is -2. So that becomes x minus -2 equals 5. And the way we're going to think of that, whenever you're subtracting a negative, I want you to think of that as x the first number stays the same. The minus sign turns to a plus. The second number turns to the opposite. So negative 2 becomes positive 2. So that means x has to equal 3 in order for that to work. So that last one, x has to equal 3. So our ordered pairs are 5, 0. Then we have 1, -4. And then we have 3, -2. So there are our ordered pairs. And now we need to graph them. So I'm going to take my equation, put it down here, and here's the 3 points we need to locate in our graph. So let's do it. So let's start with 3, -2. It doesn't matter which one of these we graph first. So let's do 3, -2. And so 3, -2 means over 3 down 2. Over 3 down 2. Get this guy out of the way. I don't know where it's going to go. Oh, it looks like I'm going to get it, put it in the way. So now let's do 5, 0. So 5, 0 means you're going to go over 5, up and down nothing. So that's going to go right here. And now I'm starting to see the idea of a line. So let me get this out of the way. All right. And so let's find out if we're right. So let's do 1, -4. So where's 1, -4? It means over 1, down 4. And that's going to be 1, 4 right here. And there is our line. And we see that since the 3 dots are forming a perfect line, it means we've probably done it correctly. And that wraps up that problem. So now we still have the same kind of equation, but this time they're not giving us values to start with. We have to make our own values. And so I'm going to show you a nice little trick. And the trick is start with your equation, x plus, in this case, 3y equals 12. And then get one of the variables all by itself. And since this guy is connected to a 3 by multiplication, and this guy isn't connected to anything, it'll be easier to isolate the x because it doesn't have a coefficient. So let's solve for x. And when I solve for x, I'm going to end up with x is equal to -3y plus 12. All right. I could have gotten x is equal to 12 minus 3y, and that would have been the same thing. X equals 12 minus 3y. That would have been the same thing. These two statements mean the same. So what I'm going to do is I'm just going to delete this one because we don't care. We don't need them both. We just need one of them. And so I'm going to use this as our main equation. And this is how we're going to create our table. All right. And so I'm going to zoom out a little bit for now. And I'm going to put this guy over here. And I want to choose some values for x and y. And that's going to be how we create our table. And so I get to choose any values for y that I want. So I'm going to choose any values. So let's make it simple. Let's choose some nice small numbers. Let's do -2. Let's do 0. Let's do +2. And let's do -4. I don't know. I'm just choosing values, right? So now I'm going to move this guy over. Now let's do the math. So let's start with -2 for y. So I'm going to replace y with -2. So I get x is equal to -3 times -2 plus 12. And so this equals 6 plus 12, which is 18. So that tells us that x is equal to 18. Oh my goodness. All right. And so now let's do, let's get this guy, let's get this guy out of the way. I'm going to shrink him down. All right, so now let's try y is equal to 0. So when y is equal to 0, we get negative 3 times 0 plus 12. So that's 0 plus 12, so that gives us 12. So that tells us that x is equal to 12 when y is equal to 0. So I'm going to shrink this down because we don't need him anymore. Now we're going to do y is equal to 2. So when y is equal to 2, you get negative 3 times 2 plus 12. So that's negative 6 plus 12. That gives us 6. So that tells us x is 6 when y is 2. And I'm going to move this down here. And then the last one, y is negative 4. So that gives us negative 3 times negative 4 plus 12. So that gives us 12 plus 12, which is 24. And so that tells us that x is 24 when y is negative 4. All right, so now the idea, if we're going to zoom over here, these ordered pairs, because x goes beyond 10 or negative 10, it's going to be really hard for me to graph these three. Although I would be able to if I had a bigger coordinate grid. So I'm going to kind of cheat a little bit, and let's put in y equals 1, because I'm noticing if I choose y equaling 1, that's going to help us a little bit. So let's do y is equal to 1. So that gives us negative 3 times 1 plus 12. And so that gives us negative 3 plus 12. So that gives us positive 9. So when y is 1, x is equal to 9. So I think now we have enough information that we can start putting our points where they go. So the first one we have is 18, negative 2. Well, 18, negative 2 goes beyond our graph, so I'm going to leave that alone. 12, 0. We can do a little bit of approximating, and we know that 12, 0 is probably going to go right about here, because you can see here's 10, 11, 12, so there's 12, 0. So I'm going to put my little point right there. And now we have 6, 2. So 6, 2, where is 6, 2 going to go? Well, it's going to go over 6 up 2. So that's going to put us right here. And then the last one that we're able to fit is 9, 1. And 9, 1 we can see, let's see, 9, 1 is going to go right about here, in that we know that 9, 1 is right there. And so you can see, here's your line. It's going to go this way, and it's going to go that way. And so if we really wanted to, let's see, does this make sense? 18, negative 2. 18, negative 2 would be, 18 would be over here. And so, yeah, negative 2 seems to make sense. And that wraps up this noisy problem. All right, so here we are going to be graphing this simple little equation. And the equation is y is equal to x. And this is such a simple, almost deceptively simple equation that a lot of students kind of get confused. And the idea is, okay, so let's make a table, x, y, and let's choose some values for our x and our y. So I'm going to move this down a little bit. And so if we want to choose some values for x, we can choose 3, 0, and negative 4, all right? And I just randomly chose those values because here's the really cool thing. If x is equal to 3, that means y is also equal to 3. So it doesn't get any easier than that. So y is also equal to 3. So I can take this, move it away. And then now if x is equal to 0, that means y is equal to 0. So now we kind of get the pattern. That really, I'm going to put this away. So we can already see the pattern that whatever x is, y is the same thing. And that's what this equation means. So that means we know that down here, y is equal to -4. So now we know our ordered pairs, 3, 3, 0, 0, and -4, -4. So we're going to take our graph. Here's our equation. And here are the 3 points that we're going to graph. So I'm going to get this guy, whoa, I'm going to get that guy out of the way. Let's see, there, and I'm going to group it, and I'm going to get it out of the way. I'm going to get this out of the way. And so now here is our graph. So where is 0, 0? Well, 0, 0 is really easy. We know where 0, 0 goes. It goes right in the origin. All right, and so 0, 0 goes right here. And then where does 3, 3 go? Well, 3, 3 is going to go over 3, up 3. And so our point is right there, 3, 3. And we see the beginning of our line, but we need that third point as confirmation that we've done it correctly. So -4, -4. So that means we're going to start at the origin, go to the left 4, down 4. And so our third and final point goes right there. And so, sure enough, we have a nice looking line right there. And so there is our graph. So keep in mind, are these the only solutions to this equation, this y equals x? No, there's an infinite number of solutions. These 3 dots happen to tell us that this is the line, and it turns out any point on this line is a solution. So that's why there's an infinite number of solutions, because you can imagine if you keep filling in these dots, what are you going to create? You are eventually going to create a nice, totally solid line. So more of the same. Let's see, I'm going to shrink this guy because I'm going to get this guy, make him a little smaller. We don't need him quite so large. Get this guy, and we're going to shrink him as well. And shrink him, move him right here. And so now I have plenty of room to work. And so the idea is our equation is y is equal to 1/4 x minus 5. Okay, so now when we've got this equation, we know that what we're going to do is we're going to create an xy table, and then we are going to make our ordered pairs, right? So the idea, though, is we're going to make our life a little bit easier, because the way we're going to make our life a little bit easier, and I'm going to put him here, all right? And the way we're going to make our life a little bit easier is because we are going to choose x's that will cancel out the 4. That's a nice little shortcut. When you see that this coefficient is a fraction, we're going to choose x's that cancel out with the 4. And so I'm going to choose 4, -4, 8, and -8. And really, I only need to choose 3, but I'm going to choose 4 just as a verification that I've done it correctly. So now let's do x is equal to 4. So what are you going to get? Well, you're going to get 1/4 times 4 minus 5. So this 4 and this 4 cancel out, so they both are replaced by 1s. So you end up with 1 minus 5, which is -4. And so I'm going to take this whole thing and I'm going to put it down here. And whoa, that's a little too small for me. And let's get in here, zoom in. and make it a little bit bigger. All right, and so make that guy a little bit smaller. There we go. All right, and so when x was equal to 4, y equaled -4. All right, so now we're going to do x is equal to -4. So you've got 1/4 times -4. And if you wanted to, you could put -4 over 1 minus 5. And that might help people understand a little bit better. So -4 and 4 are replaced by -1 and 1. And so that ends up being -1 minus 5, which ends up being -6. So that tells us that y is -6. And I can move this and get it out of the way. And then let's do 8. Because now we've got x is equaling 8. So that's 1/4 times 8 over 1 minus 5. And then the 4 and the 8 are replaced with a 1 and a 2 because we're reducing. And so that ends up being 2 minus 5, which is -3. So we know that when x is 8, y is equal to -3. And then let's do the last one, which is -8. So -8, so that's going to become 1/4 times -8 over 1 minus 5. So this becomes -2, this becomes 1. So that gives us -2 minus 5, which is -7. So we can get this out of the way. So our last value is -7. So now we could think about our ordered pairs. So we've got 4, -4. We've got -4. Oops, I want to get rid of all that. And then I want to write it again. So -4, -6. And then we have 8, -3. And then lastly, we have -8, -7. So these are our 4 points that we're going to be graphing for our line. So let's move it over, let's zoom in. And so where is -8, -7? Well, -8, -7 is going to go over and down. So -8, -7 is going to go right here. -8, -7. And then where is 4, -4? Well, that's going to be over 4, down 4. And so that's going to be right here. So I can shrink that a little bit. There we go. And it looks like we have the beginnings of a line, but let's find out, because you don't really know until you've graphed at least 3 points. So 8, -3 is going to be right here. 8, -3. And it sure looks like we have the beginnings of a line. Let's do this last one. See why we did 4, just to be sure? So -4, -6. -4, -6 goes right here. And sure enough, it really looks like we have a nice line going right here. There is our line. And sure enough, yeah, looks like we have a line. So it looks like we've probably done everything correctly. More of the same. We are going to, let's see, shrink this guy a little bit, shrink this guy a little bit. All right, so our equation is 4 minus 3x. So that's y is equal to 4 minus 3x. And that's the equation we're going to use. And so we're going to create our xy table. xy, 1, 2, 3. And you need a minimum of 3 points. And you can choose any values you want for, in this case, we're going to choose for x, because that's the easiest one. When you have a variable that's isolated, you let the other one be your, like, it's called your independent variable, the driver of what's going on here. So we're going to do, let's do -2, let's do 3, and let's do 0. So notice I'm using small numbers. I generally choose a negative, I generally choose a 0, and I generally choose a positive, just to make sure that what I'm doing is making sense. It gives me plenty of chances to make sure that I'm doing all my calculations correctly. So let's start with -2. So you get 4 minus, and now this is 3 times -2. So this is -6. So you get 4 minus -6, and that becomes plus a positive 6, which is 10. So when x is -2, y is 10. So we could shrink that down. We don't need it anymore. And so now let's do x is 3. So you get 4 minus 3 times 3. So that becomes 4 minus 9. And 4 minus 9 is -5. So when x is 3, y is -5, and we could shrink that down. We don't need it. And then the last one, when x is 0. So you've got 4 minus 3 times 0. So that becomes 4 minus 0, which is just plain old 4. So that tells you when x is 0, y is 4, and we don't need this guy anymore, so we could shrink it down. And if we wanted to, we could, we could add a fourth value here, fourth ordered pair, but we don't really need to, because you need a minimum of 3. So what are our ordered pairs? Well, we've got -2, 10. We've got 3, -5, and then we've got 0, 4. So these are going to be the 3 ordered pairs that we're going to graph. So let's zoom in. Whoa. Let's zoom in and let's plot our points. So where is -2, 10 going to go? And it turns out we're going to have to get this guy a little out of the way. Let's put it right here. So where is -2, 10? Well, it's going to go to the left 2 and up 10. So our point is not there. Let's see, not there. We want our point to go right here. So that is -2, 10. Now we have 3, -5. So where's 3, -5 going to go? Well, it's going to go over 3, down 5. So our point is going to be going over 3, down 5 right here. And so here is the beginnings of what we think is our line, and this guy is going to be our tiebreaker, and it'll tell us if we did it right. So we have 0, 4. So where's 0, 4? Don't go left or right, just go up 4. So that means our point is right here. And yep, it sure enough, it looks like our line goes right there. And so our points, this one, I'm going to put it right here. Oops, yikes. 0, -4. Oops, 0, -4. All right, so I want 0, -4. All right. And so that is our graph. So what we have is we have -2, 10, 0, 4, 3, -5, and I have a zoom out, and there is the what our line should look like. So this is more of the same. We're going to be asked to graph this linear equation, but what's different is this time we have to solve for y first, because you'll notice the x and the y are on the same side of the equation. So what we're going to do is we're going to move way over here, and we're going to do 5x plus 2y. 5x plus 2y equals 10. And we need to solve for y. So we're going to subtract 5x from both sides. And that gives us 2y is equal to -5x plus 10. Now, I could have written that 2y is equal to 10 minus 5x, but I don't want to. You're going to learn that for traditional reasons, and actually it just makes life a little bit easier because of those traditions, we always put the x value in front of the constant. All right, and then we want the y all by itself, so now we're going to divide everything by 2. So you end up getting y is equal to negative 5 halves x plus 5. All right, so now that is our equation. So I'm going to take y is equal to negative 5 halves x plus 5. I'm going to write that down again, and I'm going to move it over here. And so really, all this stuff is no longer needed. All right, so we don't need that anymore. So I'm going to shrink it down, kind of get it out of the way. And I'm going to move our equation right here. So now we are ready to make our table. All right, so our table, now you know what? I'm going to show you a beautiful, beautiful shortcut. Now, we're not quite ready for the shortcut in this series of videos, but I'm going to show you the shortcut. Are you ready? Here's your question 8 bonus. So here's a shortcut. So instead of making your table, choosing values, in this case we would choose values that are multiples of our denominator so that they cancel out. So I chose 4, negative 2, and 2 because they're going to cancel out with our 2's. Instead of doing all of that work, I'm going to show you the most amazing shortcut ever. So I'm just going to bring this over here, and here you go. So here's the shortcut. This number here, and it happens to be positive 5, tells you where on the y-axis to start. And since it says positive 5, it means our first dot is going to go right here at positive 5. Okay? Now, this number here, this is interesting. It's called the slope. And for whatever reason, we use the letter M to represent slope. And that negative 5 halves is our slope. And negative 5 is your vertical change, and 2 is your horizontal change. So we call that rise, and in this case the rise is actually going to go down, over run. So because the rise is a negative 5, it actually means we're going to go down 5. The run is positive, so it's going to go to the right. So we're going to go down 5 because it's negative 5, and then to the right 2 because it's positive 2. So we're going to go down 5. So that's going to be 1, 2, 3, 4, 5, puts us at 0. And then we're going to go over 2. So the next dot is going to go right here. And then we're going to do down 5, 1, 2, 3, 4, 5, and then over 2. So our next dot, 1, 2, 3, 4, 5, over 2, is going to go right here. And that creates a shortcut for our line. So if you wanted to, yeah, you could have made your table. You could have done all those calculations. You would have gotten the ordered pairs, and then you'd move them over. But you are going to get the exact same line. So I just showed you a beautiful shortcut. This is called the slope intercept trick or formula. And so again, that positive 5 says start at the 5. This slope means rise over run, which is down 5 over 2, down 5 over 2, down 5 over 2. Now, where you could go backwards, and you can kind of anticipate, and you can go over 2, up 5, over 2, up 5. And that's going to create the answer. So here, again, we've got that same kind of concept where first thing we have to do is we have to solve for y. So we have y is equal, oops, that's not an equal, it's y minus 3x equals 7. And we want to solve for y. We want to get y all by itself. So we're going to add 3x to both sides. So that gives us y is equal to 3x plus 7. Now, starting with that y is equal to 3x plus 7, okay, that's our equation that we're going to be graphing, right? So the shortcut that I just previously showed you, it's a really cool shortcut. And let's get that shrunk down a little bit. Okay, so the formula is, here is your intercept. So we know that we are going to start the line, or start plotting. The line actually goes forever in both directions, but that's where we're going to begin drawing our line. And we don't really know which direction it's going to go. We just know that it's going to start at 7. So there's our 7. Now, the slope in this case, remember, slope is 3. But we need to think of it as 3 over 1, because slope is always the rise over the run. So in this case, because it's a positive 3, it's going to go up 3, and that's a positive 1. So it's going to go up 3, and to the right 1. All right, so I'm going to zoom in to make it a little bit easier for us to see, and it's going to go up 3 over 1. So it's at 7, 8, 9, 10, and then over 1. So there. Now, I can't really go up 3 over 1 because we run out of graph. So I'm going to backtrack, and I'm going to go down 3, backwards 1. 1, 2, 3 over 1. And and then if I wanted to, I could do another one. 1, 2, 3 over 1. And that goes right here. And there is our line, our beautiful, beautiful line. And we get that using my cute little shortcut, so we don't have to do all that table making and all that sort of stuff. So that's called the slope intercept formula, because the 3 is your slope, which means you're going to go up 3 over 1, up 3 over 1. And then the intercept is where you're going to start that whole process. And in this case, it's 7, or positive 7. So you're going to go start at 7 and go up 3 over 1, up 3 over 1, up 3 over 1. Or you could go down 3 backwards 1, down 3 backwards 1. And you can just create your line that way. One more, only now they don't even give us the directions, but we know what we're going to do. What we're going to do is we're going to start with that 4x minus 2y equals 10. And the first thing we're going to do is we're going to solve for y, which means we want to get y all by itself. So we're going to begin by subtracting 4x from both sides. That gives us negative 2y equals negative 4x plus 10. And then, I'm going to scooch that over a little bit. And then we want to get that y all by itself, so that means we need to divide everything by negative 2. And so that gives us y is equal to 2x minus 5. Now, how did we get that? Well, right here, the negative 2 divided by negative 2 is 1, so you end up with 1y, which is just y. And then you have negative 4 divided by negative 2, and that's positive 2, x. Then you have positive 10 divided by negative 2 gives you negative 5. So there is our equation right here that we're going to be graphing. All right, so I'm going to move that over here. And so now remember the shortcut. So the shortcut is this negative 5 tells us where on our line we are going to start. And we're going to start, and I'm going to zoom in a little bit, we're going to start right at the negative 5, right here on the y-axis. And then, so that's your y-intercept. We call it, intercept. Your y-intercept. And now we know that this is our slope. So m is equal to 2, which is 2 over 1 because it's not a fraction. So you got to make it a fraction, so you just stick it on top of a 1. And that's your rise and your run. And so we know, because they're both positives, it means you're going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. So let's go back to our graph, and we know we're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And you're starting to see now, if we wanted to, we can go backwards. So we could go down 2 and left 1. And we can just keep going down 2 to the left 1. And there is our line. We have definitely created our line for this equation. And that wraps up the video, where part of the video you were learning how to make a table, and at the very end I started to show you a nice, beautiful shortcut.